Okay, so seeing that we're on the topic motion, from time to time we will have to investigate um, different scenarios or different motions that will just involve uh, vertical motion, so to speak. All right. So for this example, we're going to look at just vertical motion. Then there's also another aspect of motion when you can just look at the horizontal motion. So we have to understand that whenever motion is taking place, right, you know, it can either be along the vertical or along the horizontal, or it can be simultaneous. We'll look at that in a few. But one of the things that we have to understand when we're looking at vertical motion and horizontal motion, there are certain things that we have to make mention of, right? And they're kind of different in the sense they operate independently of each other, all right? So one of the things that we have to consider is that whenever an object is moving vertically, either upwards or downwards, there is a force of friction that would generally oppose the motion. So imagine that you throw something up in the air, right? So you throw something up in the air like a ball. Good. We expect that in its general sense that wherever there is, if we look at Newton's third law, right, there's always going to be a force that is going to act opposite to the force to where the applied force is, and that will generally be the frictional force. So what will generally stop this ball is a frictional force that is acting downwards on it. All right. But when it comes on to these calculations, when we're dealing with these calculations, we assume that frictional force is negligible. So when we say negligible, we mean that it is non-existent, so to speak. While it does exist in the real life situation, but for these types of problems, we rule it out to say that there is no frictional force that will um, impede on the motion of this ball. However, we have to now look at something different, right? While we rule out the frictional force when the ball is thrown up in the air, we now have to look at a thing what we call the acceleration due to gravity. So as we know that gravity is a force that acts downwards on objects, so to speak. So when we throw an object in the air, right, that object will be impacted by the force of gravity, which is going to be acting downwards. Now, over time, we have experiment this to say that whenever an object is tossed in the air, and it is coming back downwards, there's going to be an acceleration that is due to gravity, and that acceleration that is due to gravity is a constant value. Despite the mass of the object, it will remain constant, right? And that is just because of the force of gravity that is acting downwards on the ball. All right. So let me see right here. Okay, good. So yes. Now, in an instant when we neglect what we call it, the forces of friction, we refer to that situation as a free fall motion. All right. So whenever there's no friction that is acting on the object, we call that free fall. Just only the force of gravity that is acting down on it. All right. That's the only force. Whenever there's free fall, the only force that is acting downwards on it is the force of gravity. let's look at this problem here to get a better understanding of what is happening when it comes on to acceleration, or not acceleration, but when we have a vertical motion being taken place. And when we talk about vertical, I think we know by now that it means upwards. So it says an explosion of the ground causes a rock to be thrown vertically upwards with a speed of 20 meters per second from the ground. It says, how long will it take the rock to attain a height of 15 meters? And this is the diagram that we're working with. So here's our ground level. At this point, we can say that our displacement in terms of the y-axis is going to be 0. So we can say y naught is equal to 0 meters. Then up to 15 meters, we want to see what time or how long did it take this rock to reach or to attain the height of 15 meters. Okay, so our y, I will say y would represent the final displacement for on the y-axis. So y is going to equal to 15, positive 15, by the way, positive 15 meters, right? Whenever we are moving upwards, we have to denote it, or we generally denote moving upwards as plus. Whenever we're moving downwards, we generally denote that direction as minus. And you'll see that come into play more rigorously, especially when we look at the acceleration due to gravity, because that is acting downwards, right? We can see that it's going to attract a negative value to it, and the negative just shows the direction, because remember, acceleration is a vector quantity. So a few things here, guys. So we want to take the time at when it is at 15 meters. We don't know that. We know the initial velocity, which was given to us as positive 20 meters per second. Good. And as we said, because it's positive, it means that it's going upwards. Now, initial position is y naught, which is equal to 0 meters, because that is starting from ground level. Now, final position, we know that it's positive 15 meters, and our acceleration along the y-axis is equal to negative g, and that is pretty much negative 9.8 meters per second squared. So in order for us to solve a question like this, we have to recall, I would say, our equations of motion that we derived earlier on, right? And I'll just go ahead and insert those equations here so that we can actually see them. Now, these equations of motion can be applied to both axes, meaning it can apply to both a vertical motion and a horizontal motion. So we are going to look at these equations now and see which one would best suit our problem here. That's something that you guys have to generally do. Look at the equations and see what information do you have. So far we know we have A, which is the acceleration due to gravity. We have Y, which is the displacement. We have Y naught, right? We don't have anything to do with time. So clearly we need to find time, right? So we could use this equation here, right? We could use that one. Alright, so if we go ahead and use that one now, we would start off by saying this. So we know that S can be rewritten as, seeing that we're talking S on the y-axis, we have to denote by Y. So our final minus our initial is what we always say that S is denoted as. Now that is equal to our initial velocity. We'll just call it, can either call it v naught or we can either call it u. Ut, good, plus a half the acceleration along the y-axis, which is, we call it ay, times t squared. Now we have that information. Let's go ahead and put in some values. So we know that y is positive 15 meters minus 0 meters initial velocity, initial displacement rather. Then initial velocity now is positive 20 meters per second. And all of that is multiplying by t. And then we are going to add a half times the acceleration due to gravity, which is going downward, so that's going to be negative 9.8. Good. All of that being multiplied by t squared. With that being said, now we can do a little bit of rearrangement. Alright. So by doing that, this is what we're going to have. We're going to have positive 15 meters equal to positive 20 meters per second, all right, times t minus 4.9 t squared. Good. And so now that we have that, we can write a quadratic equation from this, and when we write that, we get negative 4.9 t squared plus 20 meters per second t minus 15 meters equal to 0. There are different ways how we could have write this. We could have wrote it like this. We could have said, or we could have say 4.9 t squared minus 20. I'm going to drop the units for a little bit. 20 t let's see. So that is plus 15 is equal to 0. All we did was to just bring this on this side and bring the 20t on that side as well. We'll basically get this. Now, with that being said, we have what we call a quadratic equation, right? And for that reason, by the way, if you go back to our mathematics class, a quadratic equation would simply be something of this nature that says a times x squared plus b times x plus c is equal to 0. That's what the quadratic equation really speaks of, where a is that variable here, right? B is this variable that is right here, that 20, and c is a constant, right? And that's just the variable there, which is 15. Now, there is a particular equation which we call the quadratic formula, and it's above here. Let me just let's see if I can bring it down here. this is our quadratic formula. Alright, so in order for us to find our t value, right, now we're in our quadratic equation here. X is in the place of t, right? So if we apply this formula, all we would simply do, wherever x is, we put t instead, right? And that is just to show you that the t is the x variable, so to speak, that we're trying to find here. All right. We could even say y to y squared for some instance. See that we're dealing with the y values, so it doesn't really necessarily matter. But having this equation, we can use this equation to find the x values, all right, or the t value, I must say. So by doing that, seeing that we know what a is already, so let's write a is equal to 4.9, b is equal to negative 20. We have to look at the signs in front, and c is equal to a positive 15. So wherever those variables come into this equation here, we'll just write it. So instead of writing x, we'll say t is equal to negative b plus or minus square root of b squared minus 4ac, all of that divided by 2a. Okay, let's see if we can go ahead and solve this now. So t is equal to, b is negative 20, alright, yeah, well, yes, but there's also a negative sign in front, so that's negative 20 plus or minus, let's rewrite that thing properly a while ago. So we have a negative b, and we know the b value is actually negative 20. So put that in bracket, square root of b squared, so that's negative 20. Negative 20 squared minus 4. A is 4.9. 4.9 close bracket times c, which is positive 15, and all of that is being divided by 2 times 4.9. all right, we're almost there. Now let's just do some mathematics here. All right. Clearly, you guys can just go ahead and just work it out to just see what it becomes, right? So t is equal to, so when you do that maths, right, you would generally go ahead and put in your values here, which would be at least, I think it's going to be 400 right here, and then you do your math, you do subtracting, you find the square root, plus or minus that. Alright, and then you're gonna get two values. Let me just do it for the sake of you realizing that you're gonna get two values. So minus and minus, right, is gonna give you a plus. So that's plus positive 20 plus or minus. Let's see what is happening on this side with the square root sign. Alright, so wow. Yeah, this calculator needs charging. Okay. Let me see what's happening now. So negative 20 squared, that's gonna give you, let me just check that again. Can't believe this calculator needs to charge, Alright, so it's going to be give you 400, so the square root of 400 minus, so 4 times 4.9 times 15 gives us a value of 294, and all of that is divided by 9.8. Alright, so we have t is equal to 20 plus or minus, let's find the square root of the difference there. So 400, by the way, minus 294, that would give me square root of 106. All of that divided by 9.8. Alright, what I could do is to do this. Square root of 106. So let's say that t is equal to 20 divided by 9.8 plus or minus 10.3 divided by 9.3. Or we could do it another way. We don't have to really do it like this. We could just plus or minus all of this and divide it by the 9 point. Instead of writing out this, could have said t is equal to 20 plus or minus 10.3, all of that divided by 9.8. So what we'll generally do is to you can either work the plus first, or you can either work the negative first. It depends on what you want to do. So we say t is equal to 20 plus 10.3, all of that divided by 9.8, or you can say t is equal to 20 minus 10.3 divided by 9.8. When we do that maths, we get, let me just try it quickly, plus 10.3. So the sum of that is going to give you 30.3 divided by the 9.8. That divided by 9.8 gives me a value of, say, so in this case t is equal to 3.1 seconds, and over this side t is going to equal to 0.99 seconds. Now you're wondering why we get two time value, right, for a problem like this. It all has to boil down to the fact that when the object is tossed in the air, right? Let me just scroll up to show you. When the object is tossed in the air, generally it would pass through the 15-meter mark at least 2 times. So the first time that it will pass would be right here when it is going up. Then when it is going down, it will pass through the 15 meters point, right? So that's why you would generally get 2 time values. All right. Yeah. So from this standpoint, all the way down to another 15 meters, then that is the time that it will basically take to attain a height of 15 meters. Good. All right. So that's about it for that aspect of vertical motion, so to speak. Right. Let's see if there are any other problems related to that we can actually look at. Yes, let's look at another problem. Alright, let's look at this problem. Let's imagine that a girl flips a coin into a 50-meter deep wishing well. If she flipped the coin upwards with an initial velocity of 5 meters per second, it says how high does the coin raises, and it says how long does it take to get the coin to this point. So we're talking about this highest point, and it says how long does it take the coin to reach to the bottom of the well. It says what is the velocity when the coin hits the bottom of the well. So let's see if we can tackle this question. Now we just want to just recall our formulas. So in a case like this, guys, let's just put back our formulas in place so that we can understand where we are going, which equation we can possibly use, and all of that lovely stuff. So these are our equations that we would generally look at whenever we're talking about motion. So one of the first things they want to find out is how high does the coin raises. So guys, generally when something is tossed in the air, it's going to go up to a point, right? And when it goes up to that point, it stops, right? So no matter what goes up in the air, it will stop at some point, right? And when it stops at that point, that's when you would say it attains its maximum height, and there's a time in which we can calculate that the object takes to reach to that height. And so that's what we're going to look at now. In order for us to do that, we have to look at the information that is given to us that we can easily jump to and use. So if we look back at the question, we know the initial velocity, which is 5 meters per second. So we can say u is equal to 5 meters per second. Then we basically know the final velocity, which is going to be what we call it now. It's going to be 0 meters per second, because whenever it reaches the maximum height, as I said, it's going to stop and then fall back to the ground. So in order for us to do that, we know that information. Now we also know this. See, now we're talking about things regarding the vertical. We know that y naught, or the initial displacement, is actually 0 meters. We're trying to find y, so we don't know that. In this case, we don't have nothing to do with time. We don't know the time as yet, so time is an unknown. All right. So we can't find time, or we can't use an equation that has time in it. That is in seconds. So one of the perfect equation that we can pull on is v square is equal to initial velocity square plus 2 times acceleration due to gravity times s, which we can rewrite s by saying y minus y naught. So if we rewrite that, we're v square is equal to u square plus 2a, all of that multiplied by y minus y naught. All right, we can go ahead and put in the information that we know. We know that our initial our final velocity is going to be 0, so 0 squared is equal to 0. We know our initial velocity, which is 5 meters, so that's going to be 5 meters per second rather, so that's 5 square plus 2. We know that the acceleration due to gravity is acting downwards, seeing that the object is going up, so acceleration is acting downwards. So with that being said, it's going to have a negative value, so negative 9.8, and that's a constant, by the way, guys, and maybe in an experiment we can actually prove that. And we're trying to find we're trying to find y. So because we're trying to find y, we know the initial displacement, which is 0. We have this equation now. So all we just need to do is to do a little bit of transposition per se, and that could lend us in getting the answer. So what we're left with is 0 on this side equal to 25 plus, not plus, let's just put the minus 19.6 y. Alright, if we do a little bit of rearrangement, we would get this. We're going to get negative 25 on this side is going to equal to negative 19.y on this side. By way of division, we can divide both sides by negative 19.6, and then we pretty much just found our maximum height, which is going to be, that's going to give us a value of 1.3 meters. Alright, and some calculators you get 1.38 meters, but we can round it up a little bit. So that would accomplish that task there in terms of finding how high the coin actually was tossed. Now, there's another part of the question to say that how it says how long does it takes to reach the top. We talk about how long, we're talking about time, so we're trying to find t in this case. So for that reason, we can use any of our t equation because we would have had sufficient information now. So for argument's sake, let's just use v is equal to u plus at. Alright, when we go ahead and use that now, we know that v is going to be 0. We know initial is going to be 5 meters per second plus negative 9.8 times t. Good. So with that being said, negative 5 goes on this side, leaving us with negative 9.8 t. Divide throughout by the negative 9.8. We're left with t equal to a value of 0.51 seconds. So that's the time that it takes or took the coin to reach a height of 1.3 meters. Alright. Now with that being said, now we want to look at part C, or question C, part C, it says how long does it take to reach the bottom of the well? We're talking about time here again. Now, one quick thing, because here is where the person threw, or the girl threw, started with tossing the coin, right? And so that's our zero displacement at this point, and the coin is going downwards. We can perceive that the height below the starting point is going to be a negative value because it's going down. So the coin is being displaced negative 50 meters downwards. Because that displacement, guys, that's why we can say negative. All right. So from where the person is to where the coin is going to go, that's going to be negative 50 meters. And that's very key for us to understand in this part of the question. Now we want to find what you call it, we want to find t in that case. So this is what we have to use. We have to use that second equation that speaks the displacement, so to speak. This is a more appropriate one for us to apply. Alright? Because we don't know the velocity at which the coin hits the ground with as yet. Alright? So this is the only one we can use for now. So we know that S can be rewritten as y minus y naught is equal to ut plus a t squared divided by half. The displacement is going to be negative 50 minus the initial displacement, which is 0. All of that is equal to 5 times t plus, in this case, we know that acceleration due to gravity is acting downwards, so it's going to be a half times negative 9.8, all of that times t squared. And with that being said, we can rewrite this to say that 0 is equal to minus 4.9t plus 5t plus 50. Good. And that is in the form, wait, let me just put a square here. That is in the quadratic form. So if this is in the quadratic form, if you end up with a quadratic equation where you have t squared and t, right, and some other variable, then you would have to use the quadratic equation. This is just to show you that we're going to get two possible values at which the time, right, for the time value, so to speak. So with that being said, t is equal to negative b plus or minus square root of b squared minus 4ac, all of that divided by 2a. Alright, we know that this is a, this is b, this is c. Now remember, this negative sign has to come into play. All the signs that are in front must come into play. Alright, so with that being said, we can go ahead and write not minus 5 plus or minus square root of 5 square, we know this 25 minus 4 times a, which is 4.9, negative 4.9 by the way, yes, negative 4.9, and that is going to times by 50, which is the value for C. And with that being said, we divide that. So what we're left with now is negative 9.8 in the denominator. With that being said, guys, we can now pull together things. So T is going to equal to negative 5 plus or minus. Alright, come on, graphical pencil. Making my thing messy right now. Okay, let's try again. T is equal to 5 plus or minus. Let's go ahead and put in some information here. 25 plus 980. When we do all of this part right here, right, and add it to this, we would get not necessarily add it, but times it to that negative sign right here. We would get positive 980, and all of that is divided by the negative 9.8. So T is equal to negative 5 plus or minus. When we work out that inside of this thing here, we get square root sign of 1005. All of that divided by our negative 9.8. That being said, we can now simplify it a little. Plus or minus, and that plus or minus are minus 5 plus or minus 31.7 divided by our negative 9.8. When we do all of that maths, we get T equal to 36.7 divided by negative, by the way, negative 36.7 divided by negative 9.8, or 26.7 divided by negative 9.8. And T in this case is going to equal to 3.76, or it says, or T is equal to negative 2.7. Now we generally rule out this one, but write it for the interest of the calculation, because time can never be negative. There must be some other reason why it's a negative over here. Alright, but let's just focus on this one that says 3.7. That would be the answer for that part. Now there is a final part, I believe, that says what was the velocity of the coin at the bottom of the well. So to answer that question, which is D, we would, it says what was of the coin at the bottom of the well. So simply put, we'll just use this equation that says V. We're trying to find the final velocity, so V is equal to U plus AT. We know quite a number of information, so we can pretty much go ahead and use that. And initial would have been 5 meters per second, negative 9.8 T. Good. So by way of let me check something quickly. Oh, we know T. We just found T a while ago to be 3.7. 3.7. Alright, so when we do that maths, we get 5 minus 36.26, and the outlet is equal to v, so v is equal to negative 31.26 meters per second. Now this is the answer, and clearly we expect that it would have been a negative value because the coin is moving downwards. Downwards would generally have a negative sign attached to it, so to speak, to just show us the direction. So that's about it for this thing per se, working out what you call it, vertical motion situations. All right, as you can see, we did not involve nothing to do with the horizontal motion as yet. Okay, so that's about it right now.